Now here, in question 31, they're asking us, well, the results of a survey of a student body at Central High School about television's viewing preferences are shown in this two-way frequency table. And the question is, are the students, or are the events, students is a male, and students prefer reality series, are they independent? Well, here, we can see that two events are independent if their probabilities are equal to each other. So the goal here is that we're going to be looking at what is the probability for the students to be male, and what is the probability for students to prefer reality series. We will find the probability for those two events, and if their probabilities are equal to each other, then we're going to claim that they are equal, or they are independent. I'm sorry. So let's get started. Now, first, let's find the probability. Let's find the probability. I think it's faster if I just type it. So let's try to find the probability. Let me raise this. So here, what we want to do first is to what we're going to do here is to find the probability of students which are males. Students is a male. So this is the first thing that we want to do. We want to see, well, what is the probability for those students who are male? Well, let's see. Well, let's make this a little bit bigger here. Okay. So let's find the probability. Let's look at the table here. First, we want to see how many students are male in total. So if we look at the table here, notice that here is the male section. If we add all those columns here, that will be 230. So there are 230 students who are male. So let me rewrite that because I don't like the way it looks. So we have 230 students who are males. Now, in order for us to find the probability, we got to see what is the total. So there are 230 students which are male, but notice that there are also 190 students in total. So that means that the probability for us to find students which are male is 230 divided by 490, and this is equals to 0.47. And again, to find the probability, it's always the event divided by the total. There's 230 students, which are males, and we're going to divide it by all the students. Okay, so this is the probability for students which are male. Now, what is the probability for students to prefer reality series? Okay, so what we're going to do here is we're going to find the probability of students prefers reality series here. Okay, so now we have this. Great. So now let's see, how can we find the probability of students who prefer reality series? Well, let's check out the column. Let's check the column of reality series then. So notice here that when it comes to males, there are 70 males who like to see reality series. And there are 180 total students who prefer reality series. So if you want to find the probability of those males who prefer reality series, well, there is 70 males who prefer reality series, and there's a total of 180 students who prefer reality series. If we do this in your calculator, you will see that this is equal to 0.38. Okay, great. So we have the probability for students to be male, and we also have the probability for students, and I'm pretty sure that here when they say students, they mean like male students. So that's one thing to point out here, that we will talk about males in total. Notice that the probabilities are not equal. The first probability is 0.47. The second probability It's 0.38. Because the probabilities are not equal, then the events are not independent. So in here, the events are not independent. Because the probabilities are equal to each other. They don't have the same probability for them to happen. Well, at least in this example, no. They're not independent because their probabilities are not equal to each other. Moving along, in example 32, what we have here is the following. So the question here is, so we've been given f of x, and we've been given g of x. Now, what we want to do here is we want to see what's the quotient. And again, quotient is just another way to say division. So all they're asking us is, if I'm giving you these two functions, what is the outcome if I divide them? That's all this question is asking you. So, and we have one method in order to divide polynomials, and this method is the long division method. And that's exactly what we're going to be doing here. So this is exactly what we want to find. We want to find f of x divided by g of x. F of x is here, g of x is here. Let's divide them. And if we divide using long division, this is the setup. The numerator always goes inside. Oops. The numerator always goes inside the square or inside the division. So 3x squared plus 7x minus 20. And we are going to divide this by x minus 2. Okay, perfect. So this is the setup. Now, if you remember your long division method, what we want to do is kind of look at what it's missing here. We have an x. We need to multiply by something in order to obtain the first term inside the square. So notice that x times 3x will give you the first term inside the square. So x times 3x, so that's 3x squared. Because that is true, then this is our first term in our answer here. So let's multiply this, x times 3x. So this gives me 3x squared. We also have to multiply the second term here, because when you have a numerator here, you got to multiply both. So we multiply the x, we obtain this. Now, if we multiply the negative 2, we have negative 2 times 3x. This is negative 6x. And now this is something that always confuses students. So after the multiplication, you have to change the sign. So let's change the sign. So it was a plus, it's a minus, it was a minus, now that's a plus. After you switch the sign, then we can combine like terms. So if we combine them, this cancels out. And if you add them up, that gives me 13x. Bring down the negative 20. Okay, perfect. Now we repeat the process. This is our new expression here. So now what we want to do is, again, look at x. What can we multiply in order to obtain the first term in my new expression here, which is 13x minus 20? Well, that will be 13. So if we multiply this by 13 now, we have the following. 3x times 13, well, that's 13x, which it's great because we want them to match. Now, how about negative 2? Negative 2 times 13, this is negative 26. And again, before you combine like terms, you gotta change the sign. Now that I changed the sign, then we can combine. And this is what we wanted. We always want the first term to cancel out in a long division. And if we combine this correctly, this is a 6. So now we stop here because if we look at what we have here, x, there is an expression which is 6 over x, but still, there is no expression which can give you a 6 out. So this is what we call the remainder. Usually when there's just a single number in the bottom, this is what we call the remainder. And when there's a remainder, we stop. So our answer, or at least quotient from this division, it's what we had on the top, which is going to be 3x plus 13. And then you're going to add the remainder, which it was 6. And you're always going to divide it by, what is it that we were always dividing by, which is x minus 2. So this is your final answer here. So after doing quotient, this is our final result. 3x plus 13 plus 6 divided by x minus 2. And this is exactly the form that they were asking us to find. Moving along. Now here in example 33, what we have in example 33 is the following. So they're asking us to algebraically determine the values of h and k to correctly complete the identity stated below. So what essentially they're asking us here is, if we look at the if we look at the left side of the equation, and if we look at the right side of the equation, we want to know what values of h, which is right here, and what value of k, which is right here, will make this a true statement. And we claim that an equations, or when expressions are equal to each other, if the coefficients are equal. So what we want to do is, we want to work on the right side. We're going to be distributing, we're going to be simplifying the right side. And if we make it look like the left side, all we got to do is just look at the coefficients, and that will be the value of h and k. It's easier said to be done, so let's actually work on this. So like again, all we're going to do first is just, let's rewrite the right side. So the left side, it remains the same, 2x cubed minus 10x squared plus 11x minus 7. Now, if we distribute the x, we're going to obtain 2x cubed. We're going to get h x squared plus 3x. So that's the distribution of the x. Now we distribute the negative 4. We're going to get negative 8 x squared. And we're going to get negative 4 hx. And we're going to get negative 12 plus k. So plus k at the end. All right. So this is what we have now. Notice that what we can do now, let's try to simplify what we have here. Notice that at least in here, this 2x cubed will cancel out with this 2x cubed because they're the same expression and they're on different side of the equation, so that's fine. Now, let's see, what else can we simplify? Well, just to make it easier, let me add 8x on both sides. 8x squared. Does not look like an 8. So 8x squared. Let's do it on both sides. Okay, so perfect. So we do this correctly. Let's see. If we add this 2, we're going to get negative 2x. We're going to rewrite what's left. Now, obviously here, this cancels out. We don't need it. So let's rewrite what is left. Now we got h x squared all right, so this is what we have now. Let's make this even easier now. Oh, let's add 12. Because again, all we're doing is, I'm just trying to simplify our expressions here. That's all we're doing. You could have taken a different route. The whole idea is to make the left side equals the right side. And the less terms we have on the right side, the better. So I'm just canceling terms, and I'm combining it on the left side here. That's all we're doing right now. All right, so now we have the following. 2x squared plus 11x. And if we combine these two, you're going to get a 5 here. And the right side, notice that it's pretty much the same. This cancels out, so we bring the k. All right, we're making it simple and simple and simple. What else can we combine? Well, look that here we have an x, here we have an x. Let's bring this 3x to the other side here. After we combining that, this cancels out. So here we have negative 2x squared. And if we combine this correctly, you're going to get 8x. All right, and then on the right side, we just have this. All right, well, let's stop here for a second and let's see. Is there anything we can combine? Nah. But notice what we just created here. If we just by combining some of those terms here, and again, this is square. Does not look like a 2. We said that the two sides are equal to each other if the coefficients are equal to each other. So what we have here is that, look that on the left side, the coefficient of x squared is negative 2. And if we look at the right side, the coefficient of x squared is h. So that means that for these two to be equal to each other, then h must have a value of negative 2. And the same can be said for k. Notice that here, the last term that does not have a variable is 5. And notice that in here, the last variable does not have a variable. Let me just do it in a different color. So we have a 5 and a 5. So that means that for both equations to be equal to each other, then k must be equal to 5. And that's pretty much our answer here. H has a value of negative 2, and k has a value of 5. And again, all we did, we just looked at the right side, we distribute, we worked it out, we want to make it as simple as possible so we can have it in this form. And then after this, all you got to do is just look at the coefficients. All right, so now here, example 34 now. It's a long problem. There's a lot of things going on at the same time, but there's some key words which we have to get from this problem. So here in example 4, it pretty much is asking us, well, we have two plans. We have Josh plans, and we have Jillian's plans, where Josh plans can be illustrated here, and Jillian's plans can be illustrated here. So we got two plans here, and the question that it's asking us here is, which one of the plans follows an arithmetic pattern? Now, how do we know that something is an arithmetic pattern? Here we have that an arithmetic pattern is something that have a common difference, or in some sense, the rate of change is constant. It will always be moving by a constant number. For something to be arithmetic sequence, if we were looking at some kind of a graph, an arithmetic sequence, it's a linear equation here. And just like the name suggests, a linear equation looks like a line. All right, so let's just look at the plans here. Which of the two plans have an arithmetic pattern, or pretty much which of the two graphs here follow a linear equation? Well, notice here that at least if we connect these dots, we kind of can see that we do have a linear equation here because they do follow a line. So this means that Jillian's plans follow an arithmetic sequence because it does follow a linear equation because the movement is always constant, or it moves at a constant rate. So in here, let's write down our conclusion here. And our conclusion is that pretty much what we have here is that Jillian's plan. So here we have a Jillian. This is our answer. So here Jillian's plans. This is the one that follows follows an arithmetic sequence. Oh, I'm sorry, arithmetic pattern. Why is this? Because the distance. It increases 1 mile each week. Or the rate of change. Constant. Now, how can we determine that it does increase 1 mile per week? Well, look at the x-axis, that's week. Look at the y-axis, that's mile. Kind of see that the slope here, it's 1. If you move 1 to the right, you move 1 up. If you move 1 to the right, you move 1 up. 1 to the right, 1 up. 1 to the right, 1 up. So that means that the rate of change is 1, a positive matter. So we can make that conclusion. The genus plants follow an arithmetic pattern because the distance increases by 1 mile per week due to the rate of change to be constant. So that answers the first question here. So now, notice that, okay, so they're asking us, sorry, it's just, that's fine. It follows an arithmetic pattern. But now here, what they're also asking us is the following. Well, because it does follow an arithmetic pattern, then we can write what is called a recursive definition to represent the number of miles each week. Now, for you to write a recursive definition, you need to know what is the first term in the sequence. Well, what is A1? So pretty much what is happening at the first week here, because these are my A. So this is A1, this is A2, A3, A4, the terms. So look at what happens on the first week. On the first week, we have a value of 10. So here, A1 is 10. After knowing that, we also have to write the definition of a recursive definition, which is pretty much the next term in the sequence. I don't know why it's not writing. Okay, so the first term in the sequence, the next term in the sequence, this is equal to the previous one, which is just an, plus the common difference, which I'm going to call the, where the, you can think about it as a difference. Or the rate of change that is changing. So we did say that we have a slope of 1. So if you go 1 to the right, you go 1 up, 1 to the right, 1 up, 1 to the right, 1 up. So that means that here, at least in this problem, the difference is equal to 1. So that means that in our formula, instead of writing d, we can just write 1. So this is what we call the recursive definition of an arithmetic sequence, which we know it's an arithmetic sequence because it follows an arithmetic pattern here. So remember, if you want to write the recursive definition, all you need is just the first term and the common difference. So now, the last thing that they're asking us to find here is, well, what if it says Jillian's plan has an alternative if Eleni wanted to train instead of for a full 26 miles marathon. Let's say that in week 1, it will start at 13 miles. So let's just highlight this. She knows that she will start at 13 miles, and it follows the same pattern, which I'm pretty much saying it does have the same common difference here for the half marathon. But it will continue for 14 weeks. Let's try an explicit formula in simplest form to represent the number of miles each week for the full marathon training plan here. Okay, so now if we want to find, or if we want to write an explicit formula here, we got to remember how does the explicit formula look like. The formula, or at least the genetic, or the general way to write an explicit formula is an equals a1 plus n minus 1 multiply by the difference. And if you want to write down the formula here, you got to know what a1 is. And you need to know what the common differences. But note that those values, we already have them in the previous example here. We know that A1 is 10. And we know the common difference is 1. So we have a general form. We have some values. Let's plug them in. So now we have AN equals A1, which we know has a value of 10, plus parentheses n minus 1 times the common difference, which is just 1. So times 1. So here, this will be the explicit formula, but notice that here it says that we need to write it in simplest form. So what this means is that we gotta just simplify the following. But notice here that what we can do here is that this 1, you can distribute to what's inside here. But that's not really change anything because all you're doing is just multiply by 1. So we have AN equals 10 plus n minus 1. And if we combine these two terms here, then we're going to have AN equals, well, we're going to have n plus, hold on, I think I did a mistake here. Yes, I did a mistake here because I did not read it correctly. You should not do this. Here, A1. A1 is 10 on the previous example here, but now here we're looking at something different. Here it says that the week 1 will start at 13 miles. Because week 1 will start at 13 miles, then A1 is not 10. I'm sorry, it's my mistake. Because we start at 13 miles, then that means that A1 is equal to 13. So all we gotta do here is just change this. I'm sorry, A1 should be 13 instead of 10. Because it does say here, like week 1, it starts at 13 miles, so that's pretty much saying that A1 is 13. We have 13 here, then we have 13 here, but the rest is the same. And now if we combine this correctly, we're going to have n plus 12. So that takes care of example 34. Now, this concludes this video. Next up, we will talk about example 35 all the way to 37.